Hello YouTubers! In this video we're going to be going through LeetCode problem 119, which is Pascal's triangle 2. Given an integer row index, return the rowIndex zero indexed row of the Pascal's triangle. So in Pascal's triangle, each number is the sum of the two numbers directly above it, as shown. So 1 plus 1 is 2. And the graph to refresh here. So 2 plus 1, 3. 3 plus 1, 4. 3 plus 3, 6. So on and so forth. So example 1, row index equals 3. So 0, 1, 2, 3. So it's 1, 3, 3, 1. In example 2, row index 0, which is output of just 1. And in example 3, row index 1 is 1 and 1. Okay. Alright, so the way we're going to do this, so let's say we want this last row. Well, we can't magically get this row without knowing the values in the previous row. So what we're going to do is rebuild the entire triangle down to the row that we need. And we're going to keep putting that in the same index. So we're not going to have... Every time we get a new row, we're not going to make a new array list. We're going to just use the existing one and have a little tutorial here that shows that. Okay, so here is our third row. The first thing we're going to do is place a 1 at the end of the existing row. Then we're going to add 3 plus 1 to get 4. Then we'll do 3 plus 3 to get 6. Then we'll do 3 plus 1 to get 4. And there we have our fourth row. So let's see how to code that. Alright. Public list of integers called getRow with passing in a row index. So this is the method that LeetCode gives us. First thing we want to do is create a list of integers, which is our return value. And we're going to instantiate that to a new array list, and we're going to do rowIndex plus 1. Now throughout this problem, we're going to have to keep dealing with the fact that indexes start at 0, but Pascal's triangle starts at 1. So we pass in, if we pass in rowIndex 0, well, Pascal's triangle doesn't have a 0 row, so we add 1, we get the first row. So it's just off by 1. So because Pascal's triangle always has 1s on the left side and 1s going down the right side, we're going to add 1 immediately. Now we're going to go through and build each row to get to the row that we need down here. So we'll have an internal loop to build each element in the row. We'll assign that equal to I, and we'll always make sure it's greater than 0, and we'll decrement j. So here we're going to, let's say we're down here on this last row. So we're going to set j, which will be, let's see, so j is, because we're working backwards here, so j will be equal to I. So this will be 0, 1, 2. I will actually be equal to 4 because we're on the fourth index, which is the fifth row. So j will be equal to 4. So 0, 1, j 0, 0, 1, 2, 3, 4. So we're going to set j equal to row get j plus get j minus 1. So let's say this is j minus 1. And we're going to add those two together and we'll get the 4. And that's pretty much it. We'll just loop through until we get all the numbers and then we get all the rows. And at the very end we're going to add 1 again. And that is the method. And then finally we're going to return the row and end the method. So let's debug this, which will clear up all the questions, I am sure. So we're going to do this last row. We're trying to get this last row. Row index of 4. Create a new array list, and we're going to add 1. So very simple, row size equal 1, array 0, value 1. So now we're going to start looping through each element in the row. Now if you look initially, because we assigned I to j, j is 0 and j is not greater than 0, so we're just going to add 1. So this is how we get the second row. It's just 1, 1. Now we're going on to the third row. And j in this case is 1, which is greater than 0, so we're going to set j plus j minus 1. So j is 1, which is 1, and j minus 1 is also the 1, and so we're going to add those two together and get the 2. And then we'll add 1 at the end. So now if you look at row, it should be 1, 2, 1, which it is. So we'll just keep doing this until we get to the row we need. Okay, so I is 2, which means j is 2. So 0, keep in mind that we're still using the same array. So 0, 1, 2. So j is 2. 2 minus 1 is 1. And 2. So 2 and 1. So 0, 1, 2 plus 1. 0. I'm confusing the numbers with the indexes. With index 1, which has a value of 2. So 2 plus 1 is 3. And it's going to do that twice. And then we'll add 1 at the end. So now it should be 1, 3, 3, 1. Okay, now we're on to the final row, where I is 3, which makes j 3. So 0, 1, 2, 3. So we're going to start here with this value. So this is j minus 1. So now we're going to add those two together and get the 4. Now we're going to add 3 plus 3 and get the 6. And now we're going to add 3 plus 1 and get the 4. And at the very end, we'll add the 4. Or add the 1. All right, so now you look at the index, and it's 1, 4, 6, 4, 1, which is what we want. So return that, and that is the answer. Now, if you look at the solution, 1, 4, 6, 4, 1, and that is exactly the result that we want. So let's run this through LeetCode and see what we get. Success. Submit that. Faster than 77.99% and use less than 83.47% memory. I always like to run it twice to see if I can get better. Ooh, less than 95% memory. Just because LeetCode can be wonky sometimes with the results. All right, the last thing we'll do is the time and space complexity. The time to run this, because we have to do 2 for loops, it's O of n squared. So if we increase the size of these loops, or increase the size of n, it increases the number of times we have to go through each loop. Now space complexity is just O of n because we're reusing the same array. So it doesn't matter how many, the 2 loops, because the space needed to do that never changes. And that is it. So once again, thank you for watching. Let me know if you have questions, and we will see you next time.